Humans have always speculated about the nature of mind, thought, and language, and searched for discrete representations of their knowledge. Aristotle tried to formalize this speculation by means of syllogistic logic, which remains one of the key strategies of AI. The first is a hierarchy was created in 260 by Porphyry of Tyros. Classical and medieval grammarians explored more subtle features of language that Aristotle shortchanged, and mathematician Bernard Bolzano made the first modern attempt to formalize semantics in 1837. Early computer design was driven mainly by the complex mathematics needed to target weapons accurately, with analog feedback devices inspiring an ideal of cybernetics. The expression artificial intelligence was introduced as a digital replacement for the analog cybernetics. Much of the original focus of artificial intelligence research draws from an experimental approach to psychology, and emphasizes what may be called linguistic intelligence, best exemplified in the Turing test. Approaches to artificial intelligence that do not focus on linguistic intelligence include robotics, and collective intelligence approaches, which focus on active manipulation of an environment, or consensus decision-making, plus drawing from biology and political science when seeking models of how intelligent behavior is organized. AI also draws from animal studies, in particular with insects, which are easier to emulate as robots, see artificial life, as well as animals with more complex cognition, including apes, who resemble humans in many ways but have less developed capacities for planning and cognition. Some researchers argue that animals, which are apparently simpler than humans, ought to be considerably easier to mimic. But satisfactory computational models for animal intelligence are not available. Artificial intelligence began as an experimental field in the 1950s, with such pioneers as Alan Newell and Herbert Simon, who founded the first artificial intelligence laboratory at Carnegie Mellon University, and John McCarthy and Marvin Minsky, who founded the MIT AI Lab in 1959. They all attended the Dartmouth College Summer AI Conference in 1956, which was organized by McCarthy, Minsky, Nathan Rochester of IBM and Claude Shannon. Historically, there are two broad styles of AI research: the NEETs and Scruffies. NEAT, classical or symbolic AI research, in general, involves symbolic manipulation of abstract concepts, and is the methodology used in most expert systems. Parallel to this are the Scruffy, or connectionist, approaches, of which artificial neural networks are the best known example, which try to evolve intelligence through building systems, and then improving them through some automatic process rather than systematically designing something to complete the task. Both approaches appeared very early in AI history. Throughout the 1960s and 1970s, Scruffy approaches were pushed to the background, but interest was regained in the 1980s when the limitations of the NEAT approaches of the time became clearer. However, it has become clear that contemporary methods using both broad approaches have severe limitations. Artificial intelligence research was very heavily funded in the 1980s, by the Defense Advanced Research Projects Agency in the United States, and by the Fifth Generation Computer Systems Project in Japan. The failure of the work funded at the time to produce immediate results, despite the grandiose promises of some AI practitioners, led to correspondingly large cutbacks in funding by government agencies in the late 1980s, leading to a general downturn in activity in the field known as AI winter. Over the following decade, many AI researchers moved into related areas with more modest goals such as machine learning, robotics, and computer vision, though research in pure AI continued at reduced levels. Modern AI began in the 1950s with the view to solving complex mathematical problems and creating thinking machines. From the outset, there were two competing approaches. One used formal rules to manipulate symbols, a logic-based approach not at all based on biology. This became known as good old-fashioned artificial intelligence, GAFI. The other camp took inspiration from how the brain works, and created artificial neural networks loosely inspired by our brains. These still had to be trained using certain procedures to solve problems. In the first 20 years, GAFI was the more successful approach, leading to much hype and significant government funding. But in real-world settings, GAFI didn't achieve its outcomes. Artificial neural networks also struggled, and in the 1970s funding dried up, research slowed and the AI community shrank. In the 1980s, improvements were made in both the rules-based GAFI systems and biologically inspired neural networks. Previously difficult problems became achievable and AI seemed promising once again. However, the hope and hype exceeded reality, and by the 1990s AI research again diminished. The latest surge of interest comes off the back of the power of deep learning, a type of biologically inspired neural network that harnesses the huge amounts of data now available, and the massive computational power and speed of today's computers. With enormous datasets, modern AI neural networks can often exceed human performance in many tasks, including pattern recognition and playing games like Go, previously very difficult for AI. Importantly, these systems can learn from experience, unlike GAFI. AI's ubiquity might now appear like it's not far off reaching human-level intelligence. But AI needs massive amounts of data to learn, unlike our brains, which can learn from a single experience.